Good morning, calculus class today. So I'm so happy about today. So just want to share the good news for you. So one of the parents told me that yesterday, one of the students I taught, and he actually got accepted by Stanford. So it's the first time ever. So the student got accepted by Stanford. Okay. So it's a university across the bay. So one of the famous college in the United States. It's ranking like either top number one or number two, always. So proud of him. Okay, so now let's take a look at that, what we're doing today. So this one, it's 5.4, part 1. So indefinite integral and the net change theorem. So record that integral f of x dx. So this one, it's capital F of x. So this one is vice versa. So capital F prime of x is the same as f of x. Okay? So we'll look at that, some of the example in a minute. Okay, so verify the differentiation, and by differentiation, that formula is correct. So what we're doing here, so the integrals of x cosine of x dx equals x sine x plus cosine of x plus c. So c is a constant. So in order to verify, that means we want to show the proof. So the way to do the proof, so that means you want to take the derivative of the results. And then eventually, we're going to end up with the exact same thing as the integrand. So now let's take a look at that. So derivative of x sine x, so we're using the product rule. So the product rule, so that will give us 1 times sine x plus derivative of sine x, which is cosine x. And then times x. And then derivative of cosine of x, which is negative sine x. Derivative of constant c is 0. So what we can do here, so sine x, negative sine x, cancel out. So what's left here is just x cosine of x. And this one, which is the same as the integrand. Okay? So let's say that you take the derivative both sides once again. So eventually, we're going to end up with the exact same thing. Okay, so now let's look at that, the second part of this. So part B. Okay, so derivative of 2, 3b squared. So that one is just the coefficient, so we'll just bring it down. But don't forget about this. This one is the product of two functions. So again, the only variable that we have is x. So a, b, and c, they're just arbitrary constant. So take the derivative of the first functions, bx minus 2a. So we do have b right here. And then derivative of radicals of a plus bx. Well, let's just rewrite this. So this one is a plus bx to the power of 1/2. So we're using the product rule, so that means the second part of the functions, we just want to bring it down. So b times the quantity of a plus bx, quantity to the power of 1/2. And now, so the first functions, so we just want to bring it down, so bx minus 2a times the derivative of a plus bx, the quantity to the power of 1/2, so which is 1/2, times a plus bx to the power of negative 1/2. But don't forget about the chain rule for this one, so multiply by the derivative of the inner functions. So times b. And I think one thing that I forgot here, so derivative of bx minus 2a, so that's b, well, which is fine. This one, there's no need to use the chain. Okay, so anything that we can verify, so let's see. Again, eventually we're going to end up with x over the quantity of a plus bx. So things that we can simplify here, so let's take a look at that. So we got 1/2 a plus bx to the power of negative 1/2 times b. So that part is quite similar to this function right here. Okay, so let's try to expand it. So we try to expand it, so we end up with, okay, so 2 over 3b squared. And then this one, try to combine them together. Well, let's just take out the greatest common factor, if that's possible. So it looks like we can take out the greatest common factor. So for this two terms right here, so which is a plus bx, quantity to the power of negative 1/2. Okay, this. And then b is also part of the greatest common factor. And then everything else that's remain here, so then that'll be a plus bx to the power of 1, so which is just a plus bx. And then don't forget to bring this one down. so plus, okay, so bx minus a times 1/2. So try to simplify it all the way through. So this one we do have a plus bx plus 1/2 bx minus a. Okay, you can always distribute the 1/2. So this one, which is plus 1/2 bx minus 1a. Okay, so just want to bring down just to get the 1/2. And now, what we got left right here, so a and a got canceled. So plus bx plus 1/2 bx, then that turns out to be 3/2 bx. Okay, so now let's just rewrite it. So once you rewrite it, so this one is 2 over 3b squared. Don't forget the greatest common factor. So a plus bx to the power of negative 1/2 times b, and then times, so this one which is 3/2 bx. Okay, so things that we can cancel here, so 3, 3, 2, 2, cross cancel, b times b, which is b squared, so b squared got canceled as well. So what's left here, it's just x all over a plus bx to the power of 1/2. And that's exactly what we got for the original integral. So this one is a little bit more complicated, so you got to be careful with the way to expand it. Again, a, b, and c, those are just arbitrary constants. And then by the time you take in the derivative, make sure that you need to apply the product rule. And then once you take the product rule, take out the greatest common factor, combine the like term, and then try to simplify it all the way through. Okay, so now let's see what else. So for the next example, so find the general indefinite integral. So indefinite integral, that means there's no boundary for the value of a and b. So we're not using part 2 of FTC. So instead of doing that, we're using just the basic integral formula. So once you integrate it, make sure that you need to get the family, the constant c at the end. So the family c, that means it shows the constant at the end. Okay, so now let's take a look at that. So this one, once you rewrite it, so it's integrals of x to the power of 3/2, and then plus x to the power of 2/3. So dx is just the indicator, it shows that x is the variable, so that's what we integrated with respect to. So integrated, so we got x to the power at 1 with 3/2, so we do have 5 over 2 divided by 5 over 2, so that means multiplied by 2/5. And then plus x to the power of 2/3 plus 1, so 1 is 3 over 3, so it's 5 over 3. And then divided by 5/3, so that means you multiply by the reciprocal, so it's multiplied by 3/5. And then add the constant c at the end. So basically that one you can just leave it. And now for the next one, before you integrate it, so anything that you can verify, expand, multiply it out, so try to do that first. So we do have integral, so v times, so expand it, so we do have v to the power of 4 plus 4v squared, and then plus 4, so it's a binomial expansion. So you're not quite sure what to do with the binomial expansions with the formula, you can always FOIL. So again, v squared, v to the power of 4, and then plus 4v squared, because that 2 times v squared times 2, which is 4v squared. And then 2 squared, then that'll be 4. Again, don't forget about the indicator, so v is the variable. And the next step, you want to multiply it out, so distribute, so we do have v to the power of 5 plus 4v to the power of 3, and then plus 4v, and then dv. So integrate it, so we do have v to the power of 6 over 6 plus 4v to the power of 4 over 4, so which is v to the power of 4, and then plus 4v squared over 2, which is 2v squared, and then don't forget to add the constant c. Okay? That's the final solution. So now let's take a look at that for C and D. So going back to trig, a lot of students do having trouble with trig, especially the trig identity. Okay, so now this one, once again, anything that can FOIL, distribute, you want to do that first. So distribute, so we can integrate the integral term by term. So secant t times secant t, which is secant square of t. And then secant t times tangent t, which is secant t times tangent t. And then dt. Integrated separately, so we do have integrals of secant square of t. So integrals of secant of t, which is tangent of t. Again, derivative of tangent of t, which is secant square of t. And then derivative, integrals of secant of t, tangent of t. Then that'd be secant of t. So the way to check this, you want to take the derivative, so which is you'll get back to the original integrand. And now, don't forget about the constant c, because this one is the indefinite integral. So again, there's no boundary, so it's always considered the indefinite integral. So this one is quite simple. It's not that difficult. But now the next one, you need to apply the trig identity. It's a double angles of sine. So for that double angles, so we do have 2 sine x and then cosine of x. And then before we integrate it, so it looks like we can just reduce. So sine x got canceled. So we do have integrals of 2 cosine of x dx. And then integrated coefficient, we can just put it out. So integrals of cosine of x, which is sine x, and then plus constant c. Okay? So now let's see what else that we have on the backboard here. So the continuation with the rest of the example. So this one, it's about the definite integral. So definite integral, that means so that involves with the boundary. So the value of a and b, the lower bound, and the upper bound. So we'll take a look at that. So first thing that you want to do, you want to FOIL. First, outside, inside, last. So the boundary, integral from 0 to 4. So 2v times 3v, which is 6v squared. And then 2v times negative 1, so it's negative 2v. And then 5 times 3v, which is 15v. And then 5 times negative 1, which is minus 5. And then put in parentheses with respect to the indicator. And now we try to integrate it term by term. So this one will end up with 6v to the power of 3 over 3 minus 2v squared over 2. So basically just using that the power rule. And then plus 15v squared over 2 minus 5v. And this one, there's no need to add the constant c, because this one is a definite integral. So that means we need to find the exact value. So the boundary goes all the way from 0 to 4. And now using that FTC part 2, so f of b minus f of a, plugging that 4 right here. So we do have 2 times 4 to the power of 3 minus 4 squared plus 15 over 2 times 4 squared. Well, this one has something wrong with this, I think. Oh, you know what? Before we do that, we can always combine the like term. Well, anyway, so we can just plug in a number, or we can combine the like term first. Okay, so 15 over 2, and then 4 squared. And then minus 5 times 4. And then minus, if we try to plug in 0, everything turns out to be 0 at the end for f of b, for f of a. So this whole thing right here, then that'll be f of b. So 4 to the power of 3, which is 64, times 2. So it's 128 minus 16. 15 over 2 times 16 minus 20. And then 0, there's no need to worry about it. So let's see things that we can cancel here. So negative 16 minus 20, negative 36. Okay, so 128 minus 36. And then this one, 15 times 8, which is 90. Wait, hold on a second. No. 8 times 5 is 40. 1 times 8 is 120, excuse me. So 128 minus 36, which is 98. And 98 plus 120. $218. So again, this one is just like finding the area under the curve from 0 to 4 of the polynomial. Okay, so just check the word one more time, making sure that combined the like term is all correct. Okay, so 4 to the power of 3, 64 times 2, 128, 4 squared 16, 15 over 2 times 16 minus 20. So reduce, so 15 times 8, which is 120. And 128 minus, well, the reason why it's 36 because I combined that negative 16 and negative 20 together. Okay, so which is 98. Wait, hold on a second. No, that's something wrong right here. So 128 minus 36. So a minus 6, that's 2. So 12 minus 3, so then that'll be 92. Sorry about that. And then 120 plus 92. So combined together, so we do have 2, 11, and then 212. Okay, so now what about for the next one here? So for the next one, so take a look at that. So this one, we can just separate them out first. So integrals from 1 to 2, so y over y to the power of 3, then that'll be 1 over y squared. You try to separate it, so it's y to the power of negative 2. And then plus 5, y to the power of 4. And then times dy. Okay, like that. Again, so separations, so the same base, we just want to reduce the power. And now the next step, so you want to integrate it, so y to the power of negative 1 over negative 1. And then plus 5, y to the power of 5 over 5. And then the boundary, it goes all the way from 1 to 2. So f of tc, part 2. So plugging a number, so we do have 2 to the power of negative 1 over negative 1. And then plus 2 to the power of 5. So this one just takes care of f of b. And then minus f of a, so plug in 1, so we do have 1 to the power of negative 1 over negative 1, plus 1 to the power of 5. Okay, f of a. So 2 to the power of negative 1, negative 1 half, so negative 1 half, 2 to the power of 5, which is 32, minus, so this one it's negative 1 plus 1, which is 0. Okay, so it's just 32 minus 1 half, which is 31 and 1 half. Okay, so now let's see what else. So for C. So for this section, we're going to divide it into two parts. So part 2 is going to be coming out from another video. Okay. So now for part C. So sine theta plus sine theta, tangent square of theta over secant square of theta. So for this one, a lot of trig function involved. So first thing that you want to do, think about the way to separate them, or the one that we can factor out or we can reduce. Okay, so again, this one is an integral from 0 to power over 3. So sine theta, compare and contrast, we do have sine of theta in common, so that means we want to take that out. So that one is just the greatest common factor. So now we do have 1 plus tangent square of theta remain. And you may be wondering, is that considered one of the trig identity? So 1 plus tangent square of theta, so this one will be written as secant square of theta. Okay, so secant square of theta. So basically secant square of theta got cancelled, top and the bottom. So now we just need to integrate it, sine of theta, which is negative cosine theta. Again, it's an integral, it's not the derivative, so it's negative cosine theta. Because derivative of cosine of theta is negative, so negative times negative, positive. And then from 0 to power over 3. So integrate it, negative, we can put it out, f of b, so cosine of power over 3, minus cosine of 0. So the negative sign can just leave it outside, so cosine of power over 3, so cosine of 60 degrees, which is 1 half. Cosine of 0, that's 1. So negative 1 half, well, it's 1 half minus 1, which is negative 1 half, negative, negative, positive, so positive 1 half. Okay? Alright, so now the last one. So let's take a look at that for D and see what happened. So integrals of absolute value of sine of x. So this one, it's a little bit special. So it looks like we can just integrate it from 0 to 3 power over 2, but you got to be really careful about this. So we try to sketch the graph for the integrand. So sine of theta, normally it's a roller coaster, like that. But this one is absolute value, so if that's absolute value, so that means we need to flip this one over. So this one's supposed to be dotted because that's just a parent graph. So once you flip it over, so it turns out to be like this. Okay, so this one you want to integrate it from 0 to 3 pi over 2. So this one's 0, this one is